In this video, I will demonstrate a part of the Java standard library that deals with collections or compound data types. In Java, a collection, also sometimes called an aggregate or container, is an object that can contain other objects. Like arrays, containers are parameterized to store objects of a given base type. Unlike arrays, they are not of predetermined length or structure. Instead, they come in all forms and shapes and, for example, differ in how to access its content or how the content is internally stored. Let's look at this example. It's a list of strings. What we do here is we declare a variable called customers in line 2 to be a list of strings, and in line 3 we instantiate an array list and bind it to that object. From then on, you can add elements to this container, and you can also retrieve the current size of the container or access individual elements by their index. List of string is actually an interface, and array list of string is a class that implements this interface. The name array list suggests that the implementation of that class is actually internally based on arrays, but there are alternatives. For example, linked lists is another alternative class which implements the list interface, and you can pick and mix the most appropriate implementation for the current task. This is a first example of what's called generics in Java, or parameterized types. You see that the list of string can just as well be a list of any other base type. For example, you can have a list of person objects here, and you can instantiate an array list of person in the same way. You need the parameter type because, for example, the signature of the add method would require to take an element of exactly that base type. We need to be careful here because collections can only store objects, and primitive data types aren't objects, which is why Java provides so-called wrapper classes around them. So instead of having lists of int, you would write lists of integers, which is a class that wraps around integer. Similarly, you could have lists of double, lists of whatever. Besides lists, there are other types of collections in the standard library, and all of those are defined within the package called java.util. Here are just a few of them. Lists we've already seen. There's also sets, queues, there's also stacks and other things, which are standard data structures that you know from algorithms. A stack, for example, is a list to which you can only write and read from one end. These operations are typically called push and pop, and this piece of code demonstrates its use. Stack is a particular type of collection, so you can also, for example, call the size method to get the current size of the collection. One very useful data structure are maps, which are collections that store key and value pairs. So they have two parameters, the type of the key and the type of the value that you would want to store. And again, maps for a given key and value type are an interface, and one very useful implementation of that interface is called HashMap. Here's a demonstration of HashMaps, very similar to the code that we've seen before. We declare and instantiate a variable called WC here, which is short for word count. That will be a map from strings to integers. In particular, it will be a hash map from string to integers. Again, map string to integer is an interface, and hash map string to integer is a class that implements this interface. You can use maps as follows. You can put some pair of key and value to it. You can get the value for a given key. You can also check if it contains a value for a given key, or remove the key value pair completely for a given keyword. Why should you use collections? The short answer is you want to make sure to use established and well-tested implementations for standard algorithmic data structures and tasks. And by doing so, you will avoid some errors by implementing things yourself, such as linked lists, which are completely standard and are necessary to implement yourself. It maximizes code reuse, and it also ensures interoperability of your code with somebody else's that might also draw on the interfaces of the standard library. Generally, it's always good practice to use parts of the standard library instead of re-implementing their functionality yourself.